I welcome you all for this lecture series on artificial intelligence and machine learning. In this lecture, we'll solve one problem by using the concepts of decision tree, and we'll see the problem. So this is the problem. So if you are looking into this problem, you can read this problem. This problem shows that, so the consider in this case, you have to consider the database about customers' purchase of all electronics. The attributes are, so if you are looking into the table, you can see the attributes are age, income, student category, rating, and the class label, that is yes or no. Y represents yes, and no means N means no. Yes, Y, yes buys computer. No means no, that is don't buys computer. The training data set is given below. Here the first column represents the serial number. There are 14 column numbers are there: age, income, student, rating, and this is the class label. These are all, we are calling it as the attributes. In this problem, we have to determine the class label using decision tree induction method and describe about decision tree. We'll see one by one. So this is the problem. All you can look into well. So attributes are age, income, student category, rating, and the class label. Here we will be calling it as yes or no. Yes means buys computer. No means do not buy a computer. So we'll first analyze for this problem. What is the problem statement? First, we'll see the problem statement is analyze the that is purchase behavior based on attributes. What are all the attributes in the problem given? Age, income, student category, rating, class label. And the primary goal of this problem is analysis is to understand decision making process behind customers' purchases of electronics. This involves studying various attributes such as age group, income level, whether the individual is a student, and the product rating. Each of these features can influence the likelihood of a customer buying a computer. By analyzing these relationships, we aim to build a model that can predict future buying behavior. And we have to construct the decision tree by using the ID3 algorithm. The ID3, what do you mean by ID3? Iterative Dichotomizer 3 algorithm is a decision tree building method that uses entropy and information gain. So ID3 means what? Iterative Dichotomizer 3. This is used to build the decision tree using entropy and information gain to decide how to split the data. By applying ID3 algorithm, we systematically evaluate the attributes' ability to classify the data and build a decision tree that captures the underlying patterns in the training data. Next, what is, so these are all the attributes: age, income, student rating, and the class level, that is yes or no. This is the training data set. And this is the trading data set. Here age, income, student rating, class label, what is given in the problem, the same thing they repeated in this table. Next, you should know what is a decision tree. A decision tree is a flow chart like structure. How we are calling it as a flow chart like a structure? A decision tree resembles a flow chart where each internal node represents a test on the attribute. Each branch represents the outcome of the test, and each leaf node represents a class label. This graphical representation makes it easy to understand the classification process. The second point is each internal node is a decision tree, possesses a question based on one of the dataset's features. For instance, a node may test whether the age of a customer is youth or senior. The outcome of this test determines the next step in the decision making path. Next, leaves. Here, the leaves represent class labels. At the end of each branch of the tree, we reach a leaf node which gives the predicted class label. In our problem, the class labels are what? Yes or no, based on whether a customer is predicted to buy a computer or not. So we are going to use either of this. In this algorithm, we are going to use ID3. First step is we have to calculate the entropy. And we have to measure the impurity in a collection of examples. So in this case, in this table, entropy means what? It quantifies the degree of disorder or impurity in the data set. Here we have to calculate how many yeses are there and how many no's are there up to this 14 categories. Higher entropy values means more uncertainty or a mix of classes, while a lower value means more purity with data points belonging to the same class. So in this case, if all examples belong to the same class, entropy is zero. And when all samples in the data sets are classified the same, such as all labels are yes or all no, there is no uncertainty, because here this will be equal means it will be getting cancelled, we are getting zero. In such cases, entropy becomes zero, which indicates a perfectly pure node. And here the entropy, this is the formula. So in this problem, we have positive means yes and negative means y. So there are 9 yeses are available in the table and 5 no's are. So 9 plus 5 is equal to 14. And if you are considering this formula, you know the formula for entropy. And here summation so minus pi into log 2 pi. So the database in this case entropy is 9 s's are there, minus 9 by 4 log 2 of 9 by 14, that is pi into log 2 of pi, 9 by 14 out of 14, minus 5 by 14 log 2 of 5 by 4. And if you are calculating this value, we are approximately getting 0.94 0. Next, for this case, we have to find out for each and every attribute, what are all the attributes are there? Age, income, student, and rating. We have to find out the information gain. So the first case is information gain. What it will do? It information gain quantifies how much the uncertainty or impurity. That means entropy is reduced after the data set is split based on particular attribute. It helps us select the most informative attribute for decision making. And here the gain is given by, you know, the formula entropy minus and the particular gain value we have to calculate it. And here the age, if you are considering youth, there are various values are available in the age category: youth, middle aged, and senior. And youth, first you have to consider how many yeses are there, and for middle age and how many no's are there. Similarly, for middle age, if you are taking all or yes, and the senior category, if you are taking, you will find out yes or no. The class labels are yes or no. So in this case, entropy, the youth, if you are taking 5 samples are there, youth. In this case, 1, 2, 3, 4, 5. Among this 5, how many yeses are there? This is no, this is no, and this is no. 3 no's and other 2 values are yes. So 5 yes, and out of 5, 2 samples are yes and 3 samples are no. Entropy for age is given by, for the youth is given by age. We have 3 variables. What are they? Age, youth, middle age, and senior. And here youth 5 samples, middle aged 4 samples. So 5 plus 4 how much? 9. 9 plus 5 14. So the totally 14. Among the 14, youth alone 5, and that among 5, 1 2 2 class labels are S, 2 3 members are no. So the entropy is found out by 2 by 5 into log 2, 2 by 5 minus 3 by 5 into log 2, 3 by 5. It is the value is given by 0.971 approximately. Similarly, middle-aged or 4 samples, as I've told, middle-aged, all class labels are yes. So yes means what is the value for, and 0 no. Entropy is 0 because equal values. And senior age is next senior 5 sample 3 yes 2 no. And if you are finding out, the value is 0.971. That means 3 divided by 5 into log 2, 3 divided by, and this the same value will be getting. We are going to get the same value 0.971. So the gain is found out by the entire entropy 0.940 minus this value by 5 by 14. How many values are there? 5 by 14 into 0.971 plus 4 by 14. This 4 by 14 into 0, the entropy value, plus 5 by 14 divided by 14 into 0.971. And if you are multiplying and adding and subtracting from this, we are getting 0.246 in this case. This is the step 2. Next, information gain for the, what is the next data set? Next data set is the students. And age we found out. So from this, after calculating the weighted average entropy post split in this case, we subtracted from the original entropy here. And then what you are getting, we subtracted original entropy data set. The resulting information gain is 0.246, indicating a moderate reduction in uncertainty if split on age attribute. Next attribute is the student. Information gain for another attribute. Here student category, if you are considering in this table, this is the student, and there are two classes alone, no and yes. So how many yeses are there? 1 2 3 4 5 6 7 yeses are there. The remaining values are 7 samples, or there is 6 yes, and the remaining values are no. So if you're finding out the values are yes alone, we have to find out in the yes alone 7 samples, in that 6 are yes and 1 is no. So if you are taking yes alone, 1 2 3 4 5 6 7, all are yes except this value. Here alone we are getting 1. So we have to find out the entropy for S under student category. Minus 6 by 7 into log 2 of 6 by 7 minus 1 by 7 into log 2 of 1 by 7. The value is equivalent to 0.591. And no category, another 7. 7 plus 7, 14. 3 yes, 4 no. So minus 3 by 7 log 2, 3 by 7 minus 4 by 7 log 2, 4 by 7. It is very easy to calculate. Only thing you need to have an interest. 4 by 7, 0.985. So gain is what? 0. Oh, the entire entropy is 0.940. 0.940 minus 7 by 14. The total samples are 14 into 0.91. 7 by 14 into 950. If you are multiplying and adding, you are getting the value 0.151. Next on us, next attribute. What is the next attribute? Next attribute is rating. The rating consists of what are all the parameters? Fair, excellent. Fair, excellent. Fair alone, if you are taking, how many no's are there? How many yeses are there? So here in the here high, medium and low for the income. Similarly, the another attribute is the income, high, low, medium. In this case, first we have to take high, and in the for the high, how many s's are there? Medium, how many s's are there? Lows are there. And low, how many s and how many no's are there? This we have to find out. If you are finding out, we are going to get other values. So income categorical and has three distinct values: high, medium, low, and total values are 9. And here the entropy for the, this is the full data set for your understanding. I have written over here. Income high, subset 4 samples, 2 yes 2 no, and the entropy is 1.0. Similarly for income medium 5 samples. 0.97, yes or no, and income low, 5 samples are there. If you are adding all those values, 4 plus 5 plus 9, 5, 14 values we are getting, and 4s 1, no, the entropy if you are finding out 0.722. The weighted entropy is this is the weighted entropy, and the gain is given by 0.940, and these values 4 by 10, and here commonly we have taken 9.9. If you are subtracting from 0.940, we are getting 0.029. So similarly, another values are the rating has two values, fair and excellent. Rating of fair 8 examples, 6s 2 no. In the from this table you have to analyze it and you have to read it thoroughly, or you have to keep it in front. So I know this, so I have directly solved this problem. And 6 knows 0.811, rating excellent 6 sample. Finally, if you are adding, we have to get 14, 8 plus 4, 8 plus 6. So 3 is 3 no, entropy is 1.0. So the weighted average is weighted entropy rating is 8 by 4 into this value, 6 by 14 into this value. So the gain is given by 0.940, this value. If you are subtracting, we are getting 0.048. So what is the gain over here? 0.048. So this is the value for the gain value for the rating. So we have found out value for all the values. So the best attribute is here the age. What is the age? The gain is 0.246. What is the gain value for the age? 0.246. For student 0.151, and the other values are the income 0.029, and the rating the value 0.41. So if you are comparing all these four values, which one will give us a better value? The best attribute is the age. So the among all attribute evaluated so far, age has the highest information gain. What is the information gain for the age? 0.246. Therefore, the attribute age is selected as what? Best root node for the decision tree. By making use of this, we have to construct the tree. So root node is age. We have to split the age on three values. What are they? Youth. So age we found out based on the entropy. Age we are coming to the conclusion. This is the best attribute. This has been classified into how many cases? Youth, middle-aged, and senior. So this we have to consider, and youth, middle-aged, and senior. Now we compute the best splits within an age branch. And subtree for youth are what? Yes or no. Subtree for youth is yes or no. Check the best attribute. Student is the highest gain. So student value is yes, that is 2 yeses are there. Leaf yes. And the student no. How many no's are there? 3 no's. So the leap is no. And the subtree for middle aged is all four are yes. As far as subtree, the student is considered yes or no. So middle aged is, if you are considering, there is only two values. What are they? Only two values. Yeah, that is all fours are yes. Leaf nodes. We can call it as leaf node. And the subtree for senior is 5 sample. 3 yes, 2 no's. Best attribute is the rating. Rating given as fair. 3 samples are given. 3 yes and leap is yes. So the rating is another value fair and excellent. How many excellents are there? 2 sample and 2 no. And here leap is no. 2 samples are no. Okay, excellent. 2 samples, 2 no's. The finally leap is no. And here 3 yes, the leap is yes. So this is the final decision tree. So the final decision tree begins by branching on age attribute. From this starting point, we follow different paths depending on whether the age is youth, middle-aged, or a senior. Youth, middle-aged, or youth is a student. Youth comes under what? Student. Right. The student has been classified into yes or no. No or yes. If the person is youth, the next node is checks whether they are a student. Yes, or they are not a student. No. A student means they buy a computer. If not, it predicts no. And the senior, if you are take middle age only yes, middle aged only yes, and the senior rating is yes or no. Yes or no, senior individual, the decision is based on the product rating. If the rating is fair, the decision is yes. If the excellent, then no. And middle aged only yes, all middle aged customers in the training data bought a computer. So the model directly classifies this age group as yes without further splitting. So coming into the so the final classification summary, what we can say is that youth is, if the student is yes, yes. Student is no, no. Middle aged always yes. Seniors are fair means yes. Rating excellence means no. This is what we have discussed. And coming into the conclusion, the ID3 algorithm uses entropy and information gain. The ID3 algorithm efficiently constructs a decision tree by evaluating the uncertainty in the data set and the strategically choosing attributes that maximizing the information gain. This approach builds a tree that models decision-making processes accurately. Next, a decision tree gives a clear classification. So, one of the main benefit of decision tree is interpretability. The tree provides explicit rules. What are they? If age is yes, age is equal to youth, and the student no, then no. That are easy to understand and apply for future predictions, and it helps predict future purchases. By modeling past customer behavior and the attribute patterns, the decision tree can be used as predictive tool, and businesses can apply this model to new customers to forecast whether they are likely to buy a computer based on the attributes. So it is suitable for the categorical data set with clear splits. Hope everyone understood this simple problem in an easiest way. The remaining things we'll discuss in the next lecture. Thank you.